Number 1 on section 9.3 tells us that they've given us two facts, they want us to find the other thing. And what they've given us in this one is the vertex, which I've graphed, it's at 4, 2, and the directrix, which is y is equal to -3. Okay, what they want is the focus. That's the third thing that's missing here, that's the focus. Now the focus, if this is the vertex, the focus is going to be like somewhere up here, okay? This is a parabola, and the reason I know this is we've got the vertex here. Your directrix is always going to go in the opposite direction that your parabola is opening. So since this is, a horizontal line, it's going to open vertically. And so it's always the same distance also from the directrix to the vertex. It is from the vertex to the focus. So let's count. From here to here is -3. From here to here is 3 units because it's y equal -3. And then if I'm counting my y's from here to here, that's 2. So 3 and 2 make 5. So that means my focus is going to be 5 units up from my vertex. Well, if my vertex is 4, 2, and I'm going to go up 5, that's going to be adding 5 to the y value. That's going to be at 4, 7. So we can figure that out just by drawing a little picture here is the easiest way to do that and to think about what it means to have a parabola. I can even draw the whole parabola on here because I drew the graph so close to the side of the iPad, but even with just that part of it, I can figure this out. Okay, if you look at number 3, they've given us the vertex, and I've graphed that at 0, 0, and they've given us the focus at, they've given us the vertex at 0, 2, and the focus at 0, 0, and I've graphed that. Now the vertex is, since it's here, and the focus is at 0, 0, I know this thing's going to open down like this. Okay, now what the definition of a parabola tells me that if it's 2 units from the vertex to the focus, it's going to be 2 units up to the directrix. Every single point on a parabola is equal distance from the focus and that line that we call the directrix. So I can actually draw that line in here. It's right here. So it goes across here. I'm trying to make it dotted since it's, and of course, it doesn't look great. But anyway, where is that line? It's through the line y equal 4. So that's all I have to do to figure 3 out. All right, if you look at number 5, the vertex is at 1, -5, and since the focus is there, I know this thing's going to open up like this somehow. I may not have the, the points in the right spot, but I kind of have a general idea because the focus is always on the inside of the parabola. Now, the distance from the focus to the vertex, if you count it here, is 1, 2, 3 here. So that means my directrix is going to be down 1, 2, 3, from the vertex, so it's going to go through that point. It's going to be a horizontal line through that point. So if I want to find my directrix here, it's just going to be y equal -8. And again, the only idea we have to use here is that every point on this parabola is the same distance from the focus and the directrix. So if I know the distance of the focus, I can count down and get the distance of the directrix down, figure out where a point is, and draw a horizontal line through it. In number 7, they've given us the focus and the directrix, and now they actually want us to write the equation of the parabola. And the problems that we did at first, we were just trying to find a missing piece. And you know what? That's going to be a good thing to do here also. If my focus is 0, 0, and my directrix is at y equal, I believe that was 4. Yeah, I can't read. It didn't actually take on the iPad. I can draw y equal 4 up here. And what I know is that if this is the focus and this is directrix, I know the vertex is going to be halfway in between that. And it's going to be on the same line that the focus is on, the same vertical line. So it's actually going to be right here. This is my vertex. And that point is 0, 2. Now this is my HK in my equation for my parabola. And so what I kind of know is going to happen is this thing's going to open down like that. I'm going to undo it and get rid of that line I just drew because I want it to be more accurate than that. So I know my H and my K, and since it opens downward, I know that I'm going to have a -A. And if I look at the blue box on page 414, we get the equation for a parabola that opens up or down. It's y minus k equal a x minus h squared. And we know that a is equal to 1 over 4c. And what is C? C is the directrix, where y equal k minus c. Okay? So I can figure this out given this information that I have. Okay? So C also comes to play. Another place I see C show up is the focus is H K plus C. Okay, so let's first get our H and our K in. Because we figured out the vertex, we know that H is 0 and K is 2. So if H is 0, that's going to go over here. It's going to be X minus 0 squared. We're going to have an A out front. We're going to have Y minus 2, because K is 2. Okay, so that is Y minus 2 is equal to A times X squared. And what we don't know is what is A. But we can find A. We know our focus is 0, 0. Okay, well, what was our vertex? Our vertex was, this is our focus here, our vertex was 0, 2. So if you look, where C comes into play, C is the K. If you take the K of the vertex, which is 0 in this case, and you add C, you'll get this 2 here. That's my coordinate of my vertex. Now that's not right. Okay, the focus is K plus C. So my K here is 2. So if I want to find out if my focus is 0, if this is 0, we know that K plus C, can't even get it in, C is equal to 0. Well, we know what K is. It is 2. So 2 plus whatever C is equal to 0. If you subtract 2 from both sides, you find out that C is negative 2. So what is A here? And then come over here to work at A is actually 1 over 4C. Well, what was C? C was negative 2. So what is A? It is negative 1/8. 1 over negative 8 would be negative 1 over 8. So if I'm writing my equation now, I'm going to kind of come over here and write it in blue. I had this much of it. I just needed to find that A there, and now I know it's negative 1/8. So now I can write the equation. It's y minus 2 is equal to negative 1 over 8 x squared. And you know what I can do with that if I want to, well, I'll just leave it like that. The book leaves it like that. Sometimes people solve for y, sometimes people leave it like that. Alright, so if I want to graph this now, I can actually find some points that are decent. Let's say that I put in, I want another pair of points. I know that if this is my vertex, I've got the axis of symmetry goes down through it. So what I can do is find one other point by plugging some stuff in. And then I can find its buddy point on the other side of the axis of symmetry. So if you think about it, if I saw, this is the answer to the equation right here. But if I add 2 to both sides, I get y equal negative 1 over 8 times x squared plus 2. Okay, so let's think about a point we could plug in there. What about, one's going to be kind of hard. Let's try to think of something where we could square it and have it divisible by 8. How about 4? If I plug in x is 4, that would be negative 1 over 8, and 4 squared would be 16 plus 2. Well, negative 1 over 8 times 16 would be negative 2 plus 2, which would be 0. So if I plug in 4, I get 0. So I can put that point there. And since my axis of symmetry is coming straight down that blue dotted line I drew, then 1, 2, 3, 4 away on the other side, 1, 2, 3, 4, I'd have another point right here. And so I could kind of sketch my parabola. Now I don't know if you remember this, but when we studied parabolas, there was a little memory device about A that you could remember. First of all, that thing opens down because A is negative. But do you remember that big is the new skinny? If you have a big number like 2, 3, 4, a whole number, you get a skinny graph, and then you had fat fractions. Well, this fraction was negative 1/8 that opens down, and since it's a fraction, this is going to be a pretty fat parabola or a wide parabola. So we can kind of be, we can kind of think we've got a reasonable graph here.